Let's take a look at this example. We are going to find the polynomial of lowest possible degree that corresponds to the given graph. From the given graph, we see three x-intercepts. I'm going to make a list here. The x-intercepts, we got x -2, 0, 1 point. And the other one is 1, 0, and 2, 0. That tells us we can see that as the product of x plus 2 factor, x minus 1 factor, and x minus 2 factor for the function that we are expecting to get. And the other piece of information, y-intercept is at -2, or the order pair 0, -2. It means when x is 0, y is -2. We're going to save this for now. Next, we're going to see the behavior to help us identify the leading term or the leading coefficient and the leading power. The behavior of the graph, as we see, as x approaches -infinity, y approaches +infinity. As x approaches +infinity, or the right end of the graph, y approaches -infinity, y -infinity. This information tells us that the leading term an will be negative number, so less than 0, and the n, which is degree, gonna be the odd power. So to get the complete form of the function, we're gonna name the leading coefficient as a and expect a to be the negative number. And how do we find a? We're gonna use the y-intercept that's provided by the graph there. That means when x is 0, y is -2. So we're gonna put in here, so y -2 equals a times 0 plus 2, 0 minus 1, 0 minus 2. I'm gonna put a note here real quick. As this step, we're gonna find a by using x equals 0 and y equals -2. So now we have -2 equals a times 2 times -1 times -2, or -2 equals 4a. That gives us a equals -1/2, as what we expected to be a negative number. Now we put all together, so then we wrap it up as the polynomial of the lowest possible degree in this form is f of x equals -1/2 times x plus 2 times x minus 1 times x minus 2.